Welcome to Cosmic Bedtime. Tonight, we leave behind the noise of the world and drift into the quiet vastness above it. From up here, Earth is not a map. There are no borders, no countries, no us and them. Just a single, glowing world, delicate, alive, and astonishingly beautiful. The astronauts on the International Space Station say that once you've seen our planet from this vantage point, you are never quite the same. So, let's float together, beyond the clouds, and see our home as they do. This is life on the ISS, how seeing Earth from space changes you. You've trained for years. Endless simulations, exhausting physical exams, survival training in freezing waters and scorching deserts, countless hours in a pressure suit. You've learned to speak in acronyms, to understand checklists as if they were poetry, and to trust your crewmates with your life. And yet, no matter how much you prepare, no briefing, no photograph, no computer rendering can prepare you for this moment. The soft hum of the station surrounds you, a mix of life support fans, equipment beeps, and the faint clicking of thermal systems adjusting to the temperature extremes outside. Your hands float, weightless, as you push yourself gently toward the small round window of the cupola, the observation module aboard the International Space Station. And then you see it. Earth. Not through the filtered glow of an atmosphere, not as a horizon you've walked 1,000 times, but as a whole. A complete, radiant sphere hanging in the black velvet of space. Blue, white, green, and brown swirls wrapped in a paper-thin halo of atmosphere, glowing faintly against the infinite night. You stop breathing. It's not that you forget how. Your lungs simply hesitate, overwhelmed by the impossibility of what you're seeing. This is your home, your history, your everything, seen all at once. You've left it, and now, looking back, you understand for the first time just how fragile it is. From this vantage point, there are no borders. The political maps you memorized in school mean nothing here. You see Africa stretch into Europe, a golden-brown expanse blending into the shimmering blues of the Mediterranean. You trace the curve of the Americas, clouds casting soft shadows across the continents. The lights of cities sparkle faintly as the station drifts into Earth's night side, tiny constellations that hint at the lives unfolding below. Somewhere down there, people are stuck in traffic, sipping coffee, arguing, falling in love, worrying about tomorrow. And you're up here, circling the entire planet in just 90 minutes. The first thing you notice is motion. From the ground, the Earth feels still, dependable. From here, you realize it is anything but. Oceans churn with storms, white spirals of clouds stretching thousands of kilometers. Shadows race across mountains and valleys as the sun rises and sets 16 times every single day aboard the ISS. The planet breathes before your eyes, a living organism, pulsing with weather, tides, and life. Then comes the silence. In orbit, there is no rushing wind, no rumble of distant engines, no waves crashing on a shore. Space swallows sound whole. Looking at Earth in that silence is almost unsettling, as if you're watching a film without its soundtrack. You find yourself leaning in, trying to listen, only to realize that what you're hearing, the whir of fans, your own heartbeat, is all that exists in this place. You remember the first photographs you saw as a child, the Apollo 17, blue marble, the Apollo 8, Earthrise. Back then, they were beautiful images. Now, they are memories you've stepped into. Except this time, the frame isn't frozen. The clouds are moving. Shadows shift. Lightning flares deep within storm systems, illuminating entire regions for a heartbeat. There is something profoundly humbling in that movement. From Earth, the scale of a thunderstorm is immense. From space, you can hold it in your gaze. It becomes just one heartbeat in a planet's ongoing story. The longer you watch, the more you realize your perspective is shifting, not just physically, but emotionally. Here, there is no us and them. No national boundaries. No rivalries. You see the Amazon and Siberia, the Sahara and Antarctica, all parts of the same breathing system. From here, the conflicts of humanity are invisible. But so is the laughter, the music, the daily moments that make life worth living. Everything you love is down there, somewhere. It hits you suddenly. This view doesn't just show you the world, it shows you your place in it. NASA astronauts often say that the first glimpse of Earth from space changes them forever. They call it the overview effect, a mental shift, a profound sense of unity and responsibility toward the planet. But in these first minutes, you're not thinking about philosophy. You're thinking about the color blue. Not the pale blue of the sky on a summer day. Not the deep navy of the ocean under clouds. This is a blue you've never seen before, electric, pure, shimmering as sunlight scatters through the atmosphere. It's so vivid that you wonder if your eyes will ever see colors the same way again. And then there's the black. Space isn't the soft midnight sky of Earth. It's absolute, bottomless, infinite. Against it, Earth glows like a jewel, fragile yet defiant, as if it has no business surviving in such emptiness, and yet, here it is. You think about how easy it would be to miss this moment entirely in the rush of life. Down there, you're busy with deadlines, bills, errands. Up here, none of that follows you. You float in the cupola, forehead pressed lightly against the glass, and for the first time in a long time, you feel still. Minutes pass. Or maybe it's an hour. Time bends in orbit, tethered more to orbits and sunrises than to clocks. You know you'll have hundreds of chances to see this view in the months ahead, but something tells you the first time will stay etched in your memory in a way none of the others will. And maybe, just maybe, when you return to Earth, you'll try to carry a piece of this view with you. If the planet could speak, you imagine it would not shout. It would whisper. Look at me. I am your only home. That is the view that stops your breath. Not just because of its beauty, but because of the truth it quietly demands you to see. Astronauts have many different ways of describing it, but the story is always the same. You look out the window, and something in your mind shifts. It's called the overview effect, a term first popularized by space philosopher Frank White in 1987. He interviewed dozens of astronauts and discovered a pattern. Regardless of background, culture, or mission, they all spoke of an overwhelming sense of unity, fragility, and responsibility after seeing Earth from space. At first, it sounds almost cliché. Seeing the planet changes you. But once you experience it, you understand why words fall short. It isn't just a beautiful view, it's a reprogramming of perspective, a rewiring of how you understand life itself. The change doesn't come all at once. At first, you're busy with procedures. Life aboard the International Space Station is a constant dance of science experiments, maintenance work, exercise, and communication. But whenever you have a spare moment, you drift toward the cupola, or any available porthole, like a moth to light. Each time you look, the feeling deepens. You see the swirling storms over the Pacific, so massive they could cover entire countries, and you remember the news headlines about typhoons and hurricanes. Down there, they are disasters. Up here, they are the elegant curves of planetary weather, as beautiful as they are destructive. You watch the jagged edges of the Himalayas pass below, sunlight carving shadows into the valleys. Somewhere down there, people are walking through mountain passes, carrying firewood or leading animals. From here, you can't see them, but you know they are there. The invisibility doesn't make them less real, it makes them part of something larger. From space, there is no "my country" or "your country." No battle lines. No walls. Just one shimmering, breathing world. The thin blue line of the atmosphere, the only thing keeping life alive, becomes painfully obvious. You can almost wrap your hand around it, like holding an eggshell, and that realization is both beautiful and terrifying. Some astronauts describe it as a sudden emotional flood, tears welling up without warning, a lump in the throat, a tightness in the chest. You're not sad. You're not even happy in the usual sense. You're awake. It's strange to think that so much of human life has been lived without this view. For tens of thousands of years, we've walked the earth without knowing what it looks like in its entirety. Maps tried to capture it. Artists imagined it. Sailors guessed at the shape of continents. But until the last few decades, no one truly saw our home from the outside. Now you are among the tiny fraction of humanity who has, and it's changing the way you think about everything. When you hear about a war, you picture not just the region's name, but the actual sweep of land where it's happening. You remember the curved horizon, the color of the terrain, the proximity to rivers or mountains. The place stops being an abstract point on a map. It becomes a living part of the planet you've seen from above. NASA astronauts have reported another side effect, a kind of planetary empathy. It's not just that you care more about the environment or about people in faraway countries. It's that you feel, in your bones, that all of it is connected. When wildfires rage in Australia, you know the smoke will spread across oceans. When glaciers melt in Greenland, you imagine the water coursing through rivers, raising sea levels that will touch shores continents away. The overview effect strips away the illusion that one place's problems are isolated. You start to think about time differently too. From space, you see multiple sunrises and sunsets each day, 16, to be exact. The world spins quickly beneath you, and the night lights of entire nations flicker into view before fading into daylight again. You realize that the boundaries we draw in time, hours, days, weeks, are just as artificial as the ones we draw on land. The planet has its own rhythm, and it doesn't care about our schedules. And yet, the overview effect is not just about Earth. It's also about space itself, the infinite black around you. That vastness is humbling in a different way. Against it, the Earth seems impossibly small, almost fragile. But it's not weak. It's alive. It's the only place we know of that cradles life in such abundance. You begin to understand why some astronauts return home and struggle to adjust. Once you've seen the whole Earth suspended in space, how do you go back to worrying about trivial things? How do you return to conversations about traffic, office politics, or celebrity scandals without wanting to shake people and say, "Do you know what this place looks like from above?" Psychologists studying returning astronauts have compared the overview effect to a spiritual awakening. Not in the religious sense, though some astronauts do interpret it that way, but in the sense of having one's worldview permanently altered. You can't unsee what you've seen. And perhaps that's the point. The overview effect isn't just a gift to astronauts. It's a message, one they bring back to the rest of us. They share photographs, stories, speeches, in the hope that we can feel even a fraction of what they felt up there. Because if enough people could, maybe we'd treat our world, and each other, differently. In the cupola, you watch another sunrise ignite the edge of the planet. The atmosphere glows in thin bands, deep blue, fading to lighter blue, then pale yellow, then white. For a few seconds, the curvature of the Earth looks like the horizon of some otherworldly jewel. You know the physics behind it, scattering of light, atmospheric density, but that knowledge doesn't dull the wonder. In that moment, you think, maybe the real reason space exploration matters isn't just to reach other worlds. Maybe it's to see this one clearly, for the first time. Life aboard the International Space Station is a paradox. It's both the most extraordinary place you can imagine, and the most ordinary. At one level, you're living in humanity's most advanced home, a multi-billion-dollar laboratory traveling at 28,000 kilometers per hour, circling the Earth every 90 minutes. Outside the thin metal walls, there is the vacuum of space, the infinite darkness, and the unbroken curve of the planet. But inside, there are chores. Laundry doesn't exist here, but trash still needs to be managed. Meals must be prepared. The toilet must be maintained. Even in orbit, life is made up of 1,000 small routines. Your days, if you can even call them days, are governed not by the rising and setting of the sun, but by a strict schedule. The ISS experiences 16 sunrises and 16 sunsets every Earth day, and each one is breathtaking. Sometimes you pause just long enough to watch the sunlight break over the curve of the planet, igniting the atmosphere in bands of blue and gold. Other times, you barely notice because you're deep in an experiment or in the middle of maintenance work. Time on the ISS runs on Coordinated Universal Time, UTC. You wake, work, and sleep according to a carefully planned timetable set by mission control on Earth. Every minute is accounted for: experiments, exercise, meals, communications, maintenance, and the occasional moment to simply look out the window. On Earth, walking is something you never think about. In orbit, walking doesn't exist. You move by pushing gently off walls, handrails, or other surfaces, gliding through modules like a slow-motion ballet. There's a rhythm to it, a flow you learn over days and weeks. Push too hard, and you'll slam into the opposite wall. Push too soft, and you'll stop short, having to reach out and pull yourself along. Everywhere, Velcro strips, bungee cords, and handholds keep objects, and you, from floating away. A spoon left unattended will drift into a corner. A pen could vanish for days, only to turn up behind a piece of equipment. And the tiniest droplet of water, once released, becomes a shimmering sphere that will float until it meets a thirsty mouth or a towel. Space food has come a long way from the early days of toothpaste tubes and dry cubes. Now there's a surprising variety: rehydratable soups, tortillas with peanut butter, packets of curry or pasta. Tortillas are favored over bread because crumbs in microgravity are dangerous. They can clog air filters or get into delicate equipment. Eating is more than sustenance here. It's a ritual of connection. Crewmates gather, tethering their food to the table with Velcro, floating together to share a meal. Sometimes you record a message for family back home while eating, the packet of space lasagna hovering in front of you. Other times, you just listen to music, or trade stories about life on Earth. And occasionally, there's a treat: fresh fruit delivered on a resupply mission. Apples and oranges become treasures, their scent flooding the module in a way that reminds you painfully of home. The ISS is, at its heart, a laboratory, a place for experiments that can't be done anywhere else. The absence of gravity changes everything: how fluids mix, how fire burns, how cells grow. Scientists on Earth design experiments and astronauts carry them out, sending data and samples back down for analysis. You might start the day growing protein crystals in microgravity, switch to testing how plants respond to space conditions, and finish by examining the behavior of combustion in zero-G. Each project has potential, from medical breakthroughs to advances in materials science. Then there's the maintenance. Machines here run constantly: air filters, carbon dioxide scrubbers, water recyclers, temperature control systems. The ISS is a carefully balanced ecosystem, and even a small malfunction can have serious consequences. You might spend hours replacing a pump, fixing a filter, or tracking down a mysterious noise that turned out to be nothing more than a loose panel. In orbit, your muscles and bones don't need to work as hard, so without exercise, they begin to weaken rapidly. Astronauts are required to work out at least 2 hours a day, a mix of resistance training, cycling, and treadmill running. Running in space is strange. You're not pulled down by gravity, so you strap yourself to the treadmill with elastic harnesses. Each step is a bounce rather than a push. Your heart pumps harder, not because of weight, but because the body still needs the stress of physical effort to stay healthy. Resistance machines simulate weightlifting, using vacuum cylinders or flywheels to create force. It's not glamorous, but it's survival, the only way to return to Earth with enough strength to stand. The ISS is connected to Earth through constant communication with mission control centers in Houston, Moscow, and other partner agencies. There are scheduled video calls, emails, and phone lines that work through satellite relays. Sometimes, you call your family just to hear their voices. You tell them about the sunrise you saw over the Sahara or the lightning storm you watched flicker across the Amazon. They tell you about the weather, the traffic, the small details of home life, the things that seem so far away here. No matter how busy you are, you make time for the cupola, the panoramic observation deck with its 7 windows, the crown jewel of the ISS. You float there during breaks, looking down at the world below. Cities at night sparkle like constellations. Clouds swirl over oceans. The auroras dance at the poles in curtains of green and purple. The cupola is where the overview effect deepens. Here, Earth is not an abstract idea. It's right there, glowing and alive, silently spinning below you. You might spot a thunderstorm, or a mountain range, or the long curve of a coastline. Each sight is a reminder of the delicate beauty and isolation of life on this planet. Sleeping in microgravity is another adaptation. You have a small crew quarters, essentially a phone booth-sized room with a sleeping bag strapped to the wall. You float inside, zipped in, so you don't drift into equipment or other crewmates. Some astronauts keep the lights on dim, others prefer total darkness. You might play soft music or listen to a recording of ocean waves to relax. Outside your little room, the station hums with fans and pumps, a constant reminder that you're inside a machine keeping you alive. And always, there's the knowledge that when you wake, the view outside will be completely different. You might fall asleep over Africa and wake over the Pacific. The world turns quickly here. Daily life on the ISS is a blend of the mundane and the miraculous. You clean filters, you fix machines, you eat, you sleep, and in between, you float above the only home humanity has ever known, 16 times a day. It's a reminder that even in the most extraordinary places, life is still about routine, connection, and purpose. And perhaps, that's what keeps you human, not just the view from the window, but the small acts of living in a place where no one was ever meant to live. Living in microgravity is like living in a dream, but one where the rules of the dream are constant, relentless, and sometimes unforgiving. From the outside, it looks effortless, astronauts gliding gracefully through the station, hair floating in a soft halo, equipment suspended in midair. But this beauty hides a truth: microgravity is not a natural state for the human body. It challenges everything you know about how to live, move, eat, and even think. It's not just the absence of gravity. It's the presence of a new physics, one where inertia rules, where your own breath can push you off course, and where your body, evolved for life in 1G, slowly begins to change in ways that aren't always comfortable or reversible. From the moment you arrive on the ISS, your body begins to adapt to the lack of gravity. Muscles that used to hold you upright now have nothing to do. Bones, freed from the constant stress of supporting weight, start to lose calcium, a process called spaceflight osteopenia. Without rigorous exercise, you could lose up to 1% of your bone mass per month. Fluids in your body shift upward toward your head. On Earth, gravity pulls them down into your legs and feet. In orbit, they redistribute evenly, giving astronauts the famous puffy face and bird legs look. You might feel congested, like you have a head cold, and your eyes could be under pressure, a condition known as spaceflight-associated neuroocular syndrome, SANS, which can even change your vision. Your heart, not having to fight gravity to pump blood to your head, becomes slightly smaller. The vestibular system, your inner ear's balance organ, goes haywire at first, confused by the lack of an up or down. Some astronauts feel space sickness for days, floating between nausea and dizziness until their brain recalibrates. At first, moving in microgravity is clumsy. You push off too hard and bang into a wall. You reach for a handhold and miss, spinning slowly in midair until you grab something to stop yourself. Inertia is merciless. Once you start moving, you keep moving until something stops you. Every movement becomes deliberate. To grab a tool, you must first secure yourself, feet hooked under a restraint or a hand slipped into a rail, or you'll drift away. Even something as simple as changing clothes can turn into a slow-motion dance with sleeves and pant legs that refuse to fall into place. When working with delicate equipment, you have to be careful not to push yourself away from the workspace. Tools float, but they also float away, so you tether everything, wrenches, scissors, even pens, with cords or Velcro. Microgravity changes not only how you eat, but also what you taste. Many astronauts report that food seems bland in space. The upward fluid shift to the head can dull your sense of smell, which is tightly linked to flavor. That's why hot sauce is a favorite on the ISS, it cuts through the muted taste buds. Drinks must be consumed from sealed pouches with straws, since any spilled liquid will form floating spheres that can damage equipment or be inhaled. Eating is a careful ritual. Open the packet, scoop or squeeze out the food, guide it into your mouth, and make sure nothing escapes into the cabin. Salt and pepper come in liquid form to prevent floating grains from causing trouble. And while there's no refrigerator, there are pantries stocked with months of dehydrated meals. Fresh food is rare, arriving only on resupply ships. A single apple can become a shared experience, cut into floating wedges and savored slowly. There's no shower in space. Water doesn't fall, it clings. So astronauts bathe with rinseless wipes and no-rinse shampoo. Brushing teeth means using just enough water from a pouch to wet the brush, then either swallowing or spitting into a towel. There's no sink. Laundry? It doesn't happen. Clothes are worn until they're too dirty, then packed into trash containers that burn up upon re-entry. You learn to accept a different standard of clean, and to manage odor with limited resources. Microgravity might be the most obvious change, but the real challenge is mental. Imagine being in a place where you can never step outside without a suit. Where your entire world is a metal tube, and your companions are the same handful of people for months. The constant hum of machinery becomes the soundtrack of your life. There is no natural breeze, no change in air pressure, no rain, no open sky. You live in a perpetual indoor environment, where the temperature and lighting are controlled by systems that must never fail. Isolation, confinement, and distance from Earth can weigh heavily. That's why communication with home, recreational activities, and regular crew movie nights are vital. Laughter in orbit isn't just good for morale, it's survival. In microgravity, even basic physics behaves differently. Fire forms spheres instead of flames, burning more slowly and with lower temperatures. Fluids cling to surfaces instead of pouring. Dropped objects don't fall, they simply hover next to you until something moves them. You learn to think ahead in ways you never did on Earth. Before opening a bag, you imagine how its contents will behave without weight. Before letting go of a tool, you know exactly where it's tethered. Sleeping in space is a learned skill. Without gravity, you don't lie down, you zip yourself into a sleeping bag tethered to the wall or ceiling. You can sleep in any orientation, and without pressure points, some astronauts report the most comfortable rest they've ever had. Others find it unsettling. The lack of down makes it feel like you're endlessly suspended. The station is never truly quiet. Fans, pumps, and electronics generate a constant background noise, so many use earplugs or music to sleep. Outside your quarters, the Earth races by, sunrises and sunsets flashing past in 45-minute intervals. You learn to ignore the light changes, or embrace them as part of the dreamlike rhythm of orbit. The challenges of microgravity are real, but so are the lessons. You learn efficiency, precision, and patience. You learn to respect your body's limits and to listen to its quiet warnings. You learn to adapt, because adaptation is the only way to survive here. And perhaps most importantly, you learn that the absence of gravity doesn't mean the absence of meaning. In fact, the very difficulty of living in space is what makes every moment here precious. Microgravity strips life down to essentials: air, water, warmth, connection. Everything else is optional. And in that simplicity, you discover something profound: the fragile miracle of living, in any form, anywhere in the universe. There's a moment, a singular, irreversible moment, when astronauts first look down and see the whole Earth framed against the black void. No borders. No noise. No division between land and sea, only the living skin of a planet suspended in nothing. It's called the overview effect, and it's one of the most profound psychological transformations a human can experience. It's not just beauty. It's not even awe. It's the sudden collapse of everything you thought you knew about your place in the universe. The first time you see Earth from orbit, it doesn't feel real. Your eyes and brain struggle to process it: the vastness, the curvature, the thin line of atmosphere glowing like the edge of a soap bubble. You expect to feel small, but instead, you feel connected. On Earth, distances define us: cities, countries, continents. Up here, you realize they're illusions. There's only one home, and you're looking at it. For some, tears come without warning. Others simply fall silent, staring through the viewport for hours. The Earth moves fast beneath you, 28,000 kilometers per hour, but in your mind, time slows to a crawl. The atmosphere, from space, is terrifyingly thin. Just a faint blue haze hugging the surface. It looks impossibly delicate, a reminder that every breath you've ever taken depends on a layer of gas so thin it would vanish if you shrank Earth to the size of an apple. You see storms spiral over oceans, lightning flickering in clouds like neurons firing in a brain. You see the lights of cities, tiny webs of gold strung across continents, fragile against the darkness. And you realize, every war, every love, every birth and death has happened within that faint blue band. It's enough to make you question why we fight at all. From here, there are no others. There's only us. Almost every astronaut describes the overview effect in strikingly similar terms, as if the experience rewrites something deep in the human psyche. Edgar Mitchell, Apollo 14, you develop an instant global consciousness, the desire to do something to improve life on the planet. From out there, on the moon, international politics look so petty. Chris Hadfield, ISS commander, you can't help but be struck by the fact that everything you've ever known, every person who's ever lived, is on that little ball. Ron Garan, ISS astronaut, we are all riding through the universe together on this spaceship we call Earth, and we need to take care of it. It's as if space travel doesn't just take you to another place, it takes you to another perspective. The overview effect often triggers two conflicting emotions, a deep love for the Earth, and an aching sorrow for its vulnerability. That love is fierce. You notice every shade of blue in the oceans, the way deserts shift color with the setting sun, the glow of dawn spilling across continents. You feel a primal connection. This is your cradle, your garden, your only refuge. The sorrow comes when you realize how fragile it is, how easily it could be damaged. You remember news headlines about deforestation, melting ice caps, pollution, and now those aren't abstractions. They're wounds you can almost see. On Earth, you're trained to see maps, lines dividing nations, colors separating us from them. In orbit, those lines are gone. Rivers flow across countries without hesitation. Mountain ranges cut across politics as if human agreements don't matter. Some astronauts say it erases nationalism in an instant. Others say it deepens their commitment to protecting their homeland, but with a new understanding that it's part of something much larger. The change isn't political in the traditional sense, it's existential. You begin to see yourself not as a citizen of one country, but as a crew member of a shared ship. Why does the overview effect hit so hard? Psychologists suggest a few reasons. 1. Cognitive shift. The human brain isn't evolved to process planetary-scale images. The sudden exposure forces a reframing of reality. 2. Context collapse. In space, your senses absorb thousands of kilometers at once. Context shrinks, continents are as visible as neighborhoods. 3. Emotional overload. Awe is known to trigger a decrease in egocentric thinking. Seeing Earth from space can dissolve the sense of separateness. In other words, it's a perfect storm of perception and emotion, a moment that permanently rewires how you see everything. On the ISS, there's a small window called the cupola, a 7-panel dome facing Earth. Astronauts often drift there in their free time, just to watch. Some bring cameras. Others bring nothing but themselves. The view changes constantly, deserts under the midday sun, auroras swirling over polar ice, thunderstorms flashing over Africa. Once, an astronaut described watching the Nile River under moonlight. It glowed like silver, threading through the black land. He knew there were millions of people living along its banks, and in that moment, he felt both their presence and their fragility. Another recalled passing over his home country at night and seeing the lights of his hometown. In space, the nostalgia was overwhelming, a mix of pride, longing, and the knowledge that home was just one small sparkle among billions. The overview effect doesn't just inspire, it compels. Many astronauts return to Earth determined to protect it. They become environmental advocates, educators, and voices for global unity. For some, the shift is spiritual. They speak of feeling part of a single living organism, of sensing a universal consciousness. For others, it's scientific, a sharpened awareness of the planet's systems and their fragility. Either way, it's rarely a passing feeling. The change lingers. It shapes decisions, relationships, and priorities for the rest of their lives. Space travel is still rare, but VR simulations and high-altitude flights are giving more people glimpses of the overview effect. Projects like Space for Humanity aim to send ordinary citizens into suborbital space, hoping that the change in perspective will ripple through societies. But many astronauts say that nothing replaces the real thing, the silence, the infinite black, the living Earth floating below. To truly understand it, you have to feel the weightlessness, the fragility, the astonishing reality of your home in the cosmos. Once you've seen Earth from above, it's impossible to go back to the old way of seeing. the maps in your mind are forever altered. You understand, in your bones, that every breath, every drop of water, every heartbeat depends on a planet that is both magnificent and vulnerable. And perhaps that's the real gift of the overview effect, not just the beauty of the view, but the responsibility it plants in you. To care. To protect. To remember that in the endless expanse of space, this pale blue dot is all we have. When you first arrive on the International Space Station, the sheer novelty keeps your mind buzzing. The sensation of weightlessness, the constant drift through modules, the Earth rolling endlessly beneath you, it's intoxicating. But as days turn into weeks, and weeks into months, something else sets in: isolation. You're 400 kilometers above home, traveling at 28,000 kilometers per hour, and yet, there are moments when you feel further away than that. Not just in distance, but in reality. Life aboard the ISS is like living inside a sealed bubble, a metallic cocoon where every breath, every drop of water, every bite of food has been engineered, filtered, and recycled. The air is dry and cool, carrying a faint metallic scent from the station's systems. There are no breezes, no sense of rain or soil, no natural sound except the muffled hum of machinery. On Earth, you take for granted the background noise of life: wind in the trees, distant traffic, the bark of a dog down the street. Up here, the constant whir of fans and pumps is the soundtrack of survival. Silence would mean something's wrong. It's a reminder: without this technology, space is not just inhospitable, it's lethal. Communication with Earth is nearly instant, but it's not the same as being there. You can speak with family over video link, but there's no touch, no shared meal, no casual walk together. Birthdays, holidays, even emergencies happen without you. One astronaut recalled watching his child blow out birthday candles over a grainy video feed, smiling for the camera while his chest ached with absence. Another learned of a family illness and had to finish a maintenance task before he could respond. Duty doesn't pause for grief in orbit. Distance reshapes your relationships. You learn to be present through words alone, to send love without a hug, to accept that the world will keep turning without you. In the absence of loved ones, your crewmates become your surrogate family. You share cramped quarters, work shifts, and every meal. You celebrate small victories together, fixing a tricky piece of equipment, finishing an experiment, spotting an unusual aurora out the window. You also see each other at your worst: fatigue, frustration, the occasional short temper when stress builds up. In space, there's no storming off for a walk. Conflicts must be addressed quickly, respectfully, and with the awareness that you depend on each other for survival. Astronauts often speak of an unspoken trust that develops, a quiet understanding that each person will do whatever it takes to keep the others safe. It's not just teamwork, it's interdependence in its purest form. Isolation in space is not like solitude on Earth. It's coupled with confinement, sensory deprivation, and the constant awareness of risk. NASA and other space agencies study this intensely, using analog missions on Earth, like Antarctic stations or underwater habitats, to simulate the psychological challenges. Some astronauts describe a third-quarter effect, the period when you're far enough into the mission that the novelty has worn off, but not close enough to the end to feel relief. It's when fatigue, irritability, and homesickness peak. Coping strategies are essential: personal rituals, hobbies, scheduled exercise, and moments of quiet reflection by the cupola window. One astronaut painted tiny watercolors in space, another kept a private audio log, speaking his thoughts aloud into the recorder as a way to process them. Ironically, the thing that keeps many astronauts sane in isolation is the very view that underscores their distance, the Earth. Floating at the cupola, you can see continents, weather systems, the flicker of lightning storms, the slow dance of day into night. You start to recognize coastlines and mountain ranges as familiar friends. You might even wave to them, not because they can see you, but because you need to feel connected. Seeing home from above is a paradox. It reminds you of what you miss, but it also nourishes your sense of belonging. It's a visual anchor, a reminder that no matter how far you drift, you still have a place where you belong. There are moments when the gap between space and Earth seems to close. You might watch the northern lights shimmer over the poles and know that at that exact moment, someone you love could be looking up from the ground, seeing the same lights from below. Sometimes, communication brings unexpected joy, a message from a friend, a photo from home, a simple, thinking of you, in an email. These small connections carry enormous weight when you're floating in a metal shell above the world. Astronauts also find connection in shared human rituals, listening to music, reading poetry, even marking holidays with improvised decorations. One crew celebrated New Year's Eve 16 times in one day, once for each orbit. It was a small act of defiance against the isolation, a reminder that time, like home, is what you make of it. Living away from Earth's embrace also means living with constant awareness of danger. Micrometeoroids, equipment failures, radiation exposure, these risks are part of the background of daily life. You learn to work with that awareness, but it never disappears. The sense of vulnerability deepens the bond between crew members. You realize that in the event of an emergency, your survival depends not just on your training, but on the trust you have in each other. This shared risk sharpens your sense of connection, even as it underscores your separation from everyone else. Astronauts say that the closer you get to the end of a mission, the more you begin to mentally descend to Earth. You imagine the weight of gravity pulling you back, the feel of fresh air in your lungs, the warmth of sunlight through an open window. But they also speak of an unexpected bittersweetness. Leaving the ISS means leaving behind a unique community, a vantage point over the world that only a handful of humans have experienced. The isolation changes you, and so does the connection you find in it. Life away from Earth's embrace teaches lessons that are hard to learn any other way. The value of presence. When you can't be physically with people, you learn to be emotionally present in every interaction. The strength of interdependence. Survival depends on trust and cooperation more than on individual achievement. The power of perspective. Seeing the whole Earth daily reminds you that no matter where you stand, you are part of a larger whole. In the end, isolation in space is not just a test of endurance, it's a transformation. You leave Earth as one kind of person and return as another, carrying the quiet understanding that connection is not about proximity. It's about recognition, seeing yourself in others, no matter how far apart you are. When most people imagine space exploration, they think of rockets, astronauts in bulky suits, and stunning photos of the Earth. But the International Space Station is not just a lookout post, it's one of the most unique laboratories humanity has ever built. Here, science unfolds in a realm where gravity is nearly absent, where time, matter, and even the human body behave in ways impossible to replicate fully on Earth. The ISS is a bridge between worlds, between disciplines, and between the limits of what we thought possible and the reality we are only beginning to understand. On Earth, gravity quietly governs almost every process you can think of. It pulls water to the ground, dictates how flames rise, shapes the way plants grow. On the ISS, microgravity changes all that. Fluids don't settle, they form floating spheres. Fire doesn't flicker upwards, it forms a soft, bluish glow. Sediments don't sink. Materials mix differently. In the absence of up and down, new patterns emerge. Scientists use this altered environment to study fluid dynamics. Understanding how liquids behave without gravity has applications in everything from fuel systems to medical devices. Combustion science. Studying fire in microgravity helps design more efficient engines and improves safety in spacecraft. Protein crystallization. Without gravity distorting growth, proteins can form larger, purer crystals, aiding in drug development. One of the most exciting areas of ISS research is biomedical science. Take Alzheimer's and Parkinson's disease. On Earth, studying the proteins linked to these illnesses is challenging, their structures are hard to see clearly. But in microgravity, these proteins can grow into crystals large enough for detailed analysis. This allows researchers to better understand the molecular misfolding that leads to disease. Astronauts have also worked on experiments growing human tissue in space. Imagine being able to cultivate fully functional organoids, miniature organs grown from stem cells, to test treatments or even replace damaged organs. The ISS isn't just a lab for studying other subjects, it's a living experiment on the effects of space on the human body. Without gravity constantly pulling down, muscles and bones lose mass. Astronauts exercise 2 hours a day to combat this, but even so, bone density loss and muscle atrophy occur. Studying these changes helps scientists understand osteoporosis and muscle degeneration on Earth. The cardiovascular system also adapts. On Earth, gravity pulls fluids down into the lower body. In space, they redistribute toward the head. This can cause facial puffiness, pressure on the eyes, and changes in vision, a condition known as spaceflight-associated neuroocular syndrome, SANS. Radiation exposure is another challenge. The ISS orbits within Earth's magnetic field, but astronauts still experience higher doses of cosmic rays than on the ground. This research is vital for planning missions beyond low Earth orbit, such as to Mars. Ironically, one of the most important scientific contributions of the ISS has nothing to do with space, it's about Earth. From orbit, the station is an unparalleled platform for monitoring our planet. Climate change, tracking polar ice melt, deforestation, and sea level rise. Natural disasters, providing near real-time imagery to aid in disaster response after earthquakes, hurricanes, and wildfires. Atmospheric studies, observing lightning, auroras, and air pollution from above. The vantage point allows scientists to see large-scale patterns and subtle changes that are impossible to detect from the ground. Science on the ISS also drives technological breakthroughs. The need to maintain life and research in space pushes engineers to innovate. Water recycling systems that purify wastewater, including urine, into drinkable water. These technologies are now used in remote communities on Earth. Advanced air filtration to remove trace contaminants. Robotics like the Canadarm2, which can perform delicate repairs outside the station, paving the way for future robotic surgery or autonomous maintenance systems on Earth. The ISS is not owned by one nation. It is a collaboration between the United States, NASA, Russia, Roscosmos, Europe, ESA, Japan, JAXA, and Canada, CSA, with contributions from other nations. This cooperation extends to science. Researchers from all over the world propose and conduct experiments on the station. The data is often shared openly, creating a global scientific commons. In an era where geopolitical tensions can run high, the ISS stands as a rare example of sustained, peaceful collaboration across national boundaries. Despite the advanced technology aboard the ISS, there's something irreplaceable about having humans in the loop. Astronauts can notice subtle changes in experiments, adapt to unexpected conditions, and improvise solutions in ways robots can't. For example, one experiment involved observing how fire behaves in space. When the flames started behaving in an unpredicted way, the astronaut adjusted the parameters in real time, saving months of potential delays. This adaptability is a reminder that science is not just about data, it's about curiosity, observation, and the human capacity to ask, what if? The ISS is not just a destination, it's a stepping stone. The knowledge we gain here will shape future missions to the Moon, Mars, and beyond. Understanding how long-duration spaceflight affects the body informs medical protocols for interplanetary travel. Perfecting life support systems in orbit prepares us for habitats on other worlds. Studying how to grow food in microgravity lays the groundwork for self-sustaining space colonies. Every experiment aboard the ISS is, in some way, an investment in humanity's future off-world. It's tempting to see ISS science as distant and exotic, but its benefits are grounded in everyday life. Medical advances, cleaner water, better disaster response, and more efficient technology are direct results of research in orbit. Perhaps more importantly, the ISS represents a way of thinking, one that values curiosity, patience, and the willingness to work together across cultures and borders. Science in orbit reminds us that exploration is not just about reaching new places, it's about expanding what we know and what we can become. Astronauts often go into space expecting to be amazed by the hardware, the spacecraft, the view of stars without atmospheric distortion, the strange ballet of life in microgravity. But again and again, when they return, they speak about something they hadn't anticipated, a profound emotional and cognitive shift that happens when you see Earth from orbit. This shift has a name, the overview effect. The term was coined by author Frank White in 1987 to describe the sudden awareness astronauts feel when they see the planet from space. It's not just a pretty view, it's an overwhelming sense of unity, fragility, and interconnectedness. From 400 kilometers up, the Earth doesn't look like a collection of countries. There are no borders visible, no divisions of us and them. There's only one planet, a glowing marble suspended in the infinite dark, wrapped in a thin, delicate veil of atmosphere. Astronauts often say they realize, in an instant, that everything, every person you've ever known, every place you've ever been, is right there, in that tiny sphere. Apollo 14 astronaut Edgar Mitchell described it as an instant global consciousness and an intense dissatisfaction with the state of the world. NASA astronaut Nicole Stott calls it a feeling in your soul that we are all Earthlings. Chris Hadfield recalls that seeing Earth in its entirety made the challenges of spaceflight fade, replaced by an urgent desire to protect that shimmering, living world. Even cosmonauts from the Soviet era, trained in a very different political and cultural context, reported the same shift. From space, they felt not as representatives of a nation, but as caretakers of a shared home. Part of the overview effect comes from sheer beauty. The oceans shift from deep sapphire to turquoise near the coasts. Clouds form vast, spiraling systems over continents. The auroras shimmer like living curtains of green and red. But it's the thinness of the atmosphere that shocks many astronauts. From orbit, it looks like a fragile halo, impossibly thin compared to the size of the planet. And they realize that thin line is all that keeps life alive here. Astronauts often return from space with a changed sense of purpose. They become advocates for environmental protection, global cooperation, and peace. The overview effect can create a kind of existential urgency. It's one thing to read that Earth's ecosystems are under stress, it's another to see the planet as a whole, to watch entire forests shrink over the course of an orbit, or to see smoke from wildfires spread across entire regions. It reframes problems, not as someone else's responsibility, but as challenges for the entire human family. Psychologists studying the overview effect note that it shares characteristics with spiritual or mystical experiences. A sense of unity, feeling deeply connected to all living things. Transcendence, a shift beyond one's individual identity. Reverence, awe and appreciation for the planet and life itself. For some astronauts, it can even be disorienting at first. Seeing the Earth as one small object in the vastness of space can make human concerns seem trivial, but it can also inspire an intense desire to cherish and protect what we have. Interestingly, space agencies don't prepare astronauts for the overview effect, at least not directly. It's not part of the mission checklist. But in recent years, psychologists and educators have begun asking, can we bring this perspective down to Earth? Some suggest virtual reality simulations using real ISS imagery. Others think large-scale Earth observation projects, where students track environmental changes from satellite data, can create a similar awareness. While nothing fully replicates the feeling of floating above the planet, even small glimpses, like seeing Earthrise in lunar photographs, can evoke a fraction of that awe. From space, the Earth appears less like a rock and more like a living organism. The oceans circulate like blood. The clouds shift like breathing. Storms, currents, and seasons form patterns that feel organic. This system's view is more than poetic. It's scientifically vital. Understanding Earth as a single, interconnected system is key to addressing climate change, biodiversity loss, and resource management. The overview effect transforms that scientific understanding into a felt reality, one that astronauts carry with them long after they've returned. One of the most powerful outcomes of the overview effect is the recognition that space changes everyone the same way, regardless of background. It doesn't matter if you were born in a sprawling city or a remote village, under capitalism or communism, in wealth or in poverty. From space, the view is the same. And the sense of belonging, not to a nation, but to Earth itself, is universal. We live in an age of both unprecedented technological capability and unprecedented global challenges. Climate instability, resource scarcity, geopolitical tension, all require the kind of unity the overview effect inspires. The ISS, in this way, isn't just a lab or a stepping stone to Mars. It's a place where humans are reminded, every day, of the truth that our survival depends on seeing ourselves as one species on one planet. Not everyone can orbit Earth. But we can choose to see the world with that same sense of awe and responsibility. We can listen to the stories of those who've been there, and we can let their vision guide our choices. In the end, the overview effect is more than a phenomenon, it's a call. A call to remember that there is no planet B, and there is no us without all of us. When astronauts return from the International Space Station, they bring back more than scientific data and stunning photographs. They bring back a changed mind, and often, a changed way of living. This transformation is not just individual, it can ripple outward into families, communities, and even national cultures. Before launch, astronauts are often framed as explorers, venturing into the unknown, representing the pinnacle of human technological achievement. But after months aboard the ISS, many of them return as something closer to messengers, people carrying a story about what they have seen and felt. Former ISS Commander Chris Hadfield put it this way: "We think space changes how we look at the stars. But really, it changes how we look at Earth. This shift is not abstract. It leads astronauts to speak publicly about the fragility of our biosphere, the urgency of global cooperation, and the shared responsibility we have as Earth's inhabitants." Living on the ISS forces astronauts to adapt to an alien environment. There is no up or down. Objects float freely unless secured. Even simple actions, eating, sleeping, brushing teeth, require retraining muscle memory. This adaptation process can change how astronauts approach challenges on Earth. They develop heightened problem-solving skills, because in space, every issue must be addressed immediately and efficiently. A calm under pressure, emergencies in space leave no room for panic. A minimalist mindset, astronauts learn how little they actually need to live comfortably. These lessons, once learned in orbit, often carry over into their terrestrial lives. The ISS is a microcosm of international cooperation. Americans, Russians, Japanese, Canadians, and Europeans live and work together in a confined space for months at a time. This means astronauts don't just represent their countries, they embody a culture of shared humanity. Meals become cultural exchanges: borscht from Russia, tortillas from the US, miso soup from Japan. Music, stories, and humor cross language barriers. The crew may have different accents, but their laughter sounds the same. In a world where headlines often focus on division, the ISS quietly proves that people from vastly different systems can collaborate, even in extreme conditions. Many astronauts describe re-entry as more psychologically jarring than launch. After months of weightlessness, returning to gravity feels like wearing an invisible, crushing suit. But the real shock comes from the noise, the pace, and the narrow focus of life on Earth. On the ISS, they see the whole planet in a single glance. Back on Earth, the view shrinks to one street, one city, one daily routine. Some astronauts struggle with this transition. Others find ways to integrate their expanded perspective into everyday life, becoming advocates, educators, and bridge builders. Spaceflight often sparks new forms of creative expression. Astronauts have written books, composed music, painted, and produced documentaries inspired by their time in orbit. NASA astronaut Nicole Stott even painted watercolors aboard the ISS, watching droplets of color float in midair before they touched paper. Her post-flight work now combines art with advocacy for ocean and environmental protection. This creativity is not just about personal satisfaction, it's a way to translate the experience of space into something tangible for those who will never leave Earth. Science is central to the ISS mission, but storytelling is just as important. Data can inform, but stories inspire. Astronaut Scott Kelly's year-long mission produced valuable biological insights, but his Instagram posts, showing auroras, storms, and city lights from space, reached millions in a deeply personal way. The cultural transformation of space travel lies in this intersection, turning individual wonder into collective awareness. When astronauts visit schools, they're not just teaching about orbital mechanics or spacewalks. They're planting seeds. Children hear about floating through modules, watching lightning storms from above, and seeing the curve of Earth. They learn that cooperation across borders is not just possible, it's essential. For many, these encounters ignite dreams of careers in science, engineering, art, or diplomacy. The astronaut's transformation becomes a catalyst for the next wave of explorers, thinkers, and problem solvers. Countries involved in the ISS program often experience a subtle but significant cultural impact. Spaceflight becomes part of the national narrative, a reminder that their citizens have touched the frontier of human achievement. In Canada, Chris Hadfield's time as ISS commander boosted interest in STEM fields nationwide. In Japan, Koichi Wakata's missions became a source of national pride. In Russia, cosmonauts remain symbols of endurance and technical mastery. This pride can also foster humility, the recognition that while national contributions matter, the space station belongs to no single country. It is a shared accomplishment. For some astronauts, the cultural and personal transformation takes on a philosophical or even spiritual dimension. Edgar Mitchell's experience during Apollo 14 led him to study consciousness and human potential for the rest of his life. On the ISS, moments of solitude, watching the Earth rotate silently below, can lead to profound reflection on life's meaning and humanity's place in the cosmos. This philosophical shift can change how astronauts engage with people after their missions. They may speak less about national achievement and more about global stewardship. The ISS teaches a lesson that applies far beyond spaceflight. We are all crew members on Spaceship Earth. We share limited resources. We depend on a fragile life support system, our atmosphere and ecosystems. Cooperation is not optional, it's survival. Astronauts live this reality every day in orbit. When they return, they carry it into conversations, projects, and policy discussions. In this way, the cultural and personal transformation of space travel becomes a societal resource. Everyone will launch into space, but the principles learned aboard the ISS, adaptability, cooperation, respect for resources, and an expanded perspective, are within reach for anyone willing to embrace them. By listening to astronaut stories, supporting space exploration, and thinking beyond our immediate surroundings, we can experience our own small version of the transformation that happens 400 kilometers above our heads. When astronauts gaze down from the International Space Station, they are not just witnessing the Earth as it is, they are also, perhaps unknowingly, peering into its possible futures. From 400 kilometers above, patterns emerge that are hard to detect on the ground, glowing cities spreading like constellations, vast scars of deforestation, the slow shifting of glaciers, the swirling chaos of superstorms. In the silence of orbit, the planet reveals both its vulnerability and its resilience. And the question becomes unavoidable: what will this world look like 100 years from now? From space, you can watch change happen in real time. One day, the Amazon rainforest is shrouded in green. A month later, brown patches appear, signs of logging or fires. Coastlines subtly shift with rising tides. Rivers carry more sediment than before, evidence of upstream erosion. These changes are not abstract climate models. They are visible, undeniable truths. Astronauts have watched glaciers retreat over the course of a single mission. They've seen the bright reflection of ice give way to the dull, darker tones of open water, a transformation that accelerates warming in a feedback loop. From this vantage point, the future doesn't arrive suddenly, it approaches quietly, visible to those who know where to look. The Earth's atmosphere, from space, is a thin, glowing halo, a fragile film hugging the planet. It's so thin that astronauts often describe it as shockingly insubstantial, as if a breath could tear it away. From the ground, the sky feels infinite. From orbit, it looks finite, almost delicate. That shift in perspective forces a realization: everything we know, love, and depend on exists within that fragile layer. The ISS itself is a microcosm of this truth. It has a closed-loop life support system: water is recycled, air is filtered, waste is managed with care. On Earth, we have no resupply missions from elsewhere in the cosmos. If we damage our systems, we must repair them ourselves. One of the most profound effects of viewing Earth from space is the disappearance of borders. Continents appear as vast, unbroken landmasses. Political boundaries, so deeply ingrained in our maps and minds, are invisible. Even regions in conflict look peaceful from above, lit by the same sunlight, covered by the same clouds. This realization carries a message: the future of Earth is a shared project. No country can unilaterally protect the atmosphere or prevent sea level rise. Just as the ISS is maintained through international cooperation, so must the planet be. City lights from space are breathtaking, golden webs stretching across continents. But they also tell a story. The spread of lights marks urban expansion, often at the cost of farmland and forests. Some regions blaze with artificial brightness, while others remain dark due to poverty or underdevelopment. Astronauts have seen sudden blackouts after disasters: hurricanes, earthquakes, wars. These moments are stark reminders that technological civilization is both powerful and fragile. At night, Earth shows its pulse. And that pulse is quickening. Satellites and ISS observations are already vital in tracking environmental change, natural disasters, and resource use. From predicting hurricanes to mapping wildfire spread, the SpaceEye offers both warning and guidance. In the future, these orbital perspectives could become even more integrated into daily decision-making. Precision agriculture guided by satellite data to reduce waste and improve yields. Real-time disaster relief coordination using space-based imagery. Global monitoring of greenhouse gas emissions, holding nations accountable. Space may be the key not just to exploring other worlds, but to sustaining our own. When astronauts return from space, many speak about an unshakable moral clarity, the need to protect the Earth at all costs. They've seen its beauty without the noise of politics or economics, and that makes them fiercely protective. In the future, we might see the rise of Earth stewards, leaders, scientists, and citizens who adopt this orbital ethic even without leaving the ground. It's an ethic rooted in three truths. 1. We are all connected. 2. Our resources are finite. 3. There is no planet B, at least not yet. From orbit, both hopeful and grim futures are imaginable. In 1, humanity learns from its mistakes, embraces clean energy, restores forests, and stabilizes the climate. In another, deserts expand, seas rise, and cities fall into ruin. The ISS is proof of what's possible when nations work together toward a common goal. But it's also a reminder of how precarious that cooperation can be. The choice between utopia and collapse will be made here on Earth, but it will be visible from space. The overview effect, that shift in consciousness astronauts experience when seeing Earth from space, is transformative for individuals. The question is, can we scale it to billions of people? Virtual reality, immersive space imagery, and educational initiatives could allow more people to experience a taste of that perspective. If enough of us could see the planet as astronauts do, the hope is that it might spark collective action. The ISS is not humanity's final destination. Lunar bases, Mars missions, and deep space habitats are on the horizon. These will expand our perspective even further. Paradoxically, the more time we spend away from Earth, the more precious it may become to us. A home is never more valued than when you've left it behind. Future explorers may carry the same message as today's astronauts, only louder, more urgent: protect Earth, for it is the only place we truly belong. If the view from space teaches one lesson above all, it's this. The planet is not just where we live. It is a living, breathing system, and we are part of it. The future is not something that will happen to Earth. It is something we are building, moment by moment, choice by choice. From the ISS, the horizon curves gently, endlessly. It looks eternal. But astronauts know the truth, it's only eternal if we care for it. From the ISS, the Earth feels both small and infinite. The view from space reminds us that we are one species, sharing one fragile home. And perhaps, if we can see it together from above, we can learn to care for it together from below. Thank you for joining me tonight, here at Cosmic Bedtime. Until we meet among the stars again. Good night.